we're going to be looking at geometric sequences and series. Here's some vocabulary for us on sequences. A geometric sequence, we've already dealt with the arithmetic where it's adding the same number every time. A geometric sequence is found by multiplying by the same number every time. So that number we're multiplying every time is called a common ratio, and we use the variable r for that. R cannot be 0, otherwise it would just be all the same number. We can find the common ratio by dividing the second term by the first term, a2 divided by a1. You could do a3 divided by a2. And the formula to write the nth term of a geometric sequence is an equals a1 r to the n minus 1 power. These are exponential equations. They're exponential patterns. So, can we find the pattern? Remember, this is a watch me do a problem, pause the video, try the problem next to it so that you get a chance to process that. Then you unpause it and watch me do the second problem. Okay, so here's my problem, find the missing term. My pattern is 324, 108, 36, 12. Now it's kind of difficult to see what this pattern is until I get to count these smaller numbers. So like we said, we can do a2 divided by a1, 108 divided by 324. We could do 36 divided by 108, and we could do 12 divided by 36. If these are all the same number, then it's a geometric sequence. So when I do 108 divided by 324, I get 1/3. 0.33333. So 1/3. When I do 36 divided by 108, I get 1/3. When I do 12 divided by 36, I get 1/3. So we're looking at what is being multiplied every time, not that we are dividing by 3 every time. So when I see 12 times 1/3 is 4, so my missing term is 4. Okay, go ahead and look at the next one. 16, 24, 36, 54. Go ahead and divide these. 24 divided by 16, 36 divided by 24. Pause it, find that common ratio, and multiply the last term by that common ratio to get the missing term. Okay. We should have paused it. We should have 24 over 16, which is 1.5, or 3/2. We do 36, we do 36 over 24, we also get 1.5. So 54 times 1.5 is 81. Okay. We generally like to look at our r's in fractions. We can generally do fractions without a calculator more than we can decimals. So my r is 3/2, my missing term is 81. So the next thing we're going to need to do is find the sixth term, find a missing term of the geometric series or sequence. It's actually sequence. Remember that a sequence is just a list of terms. A series is the sum of them. We'll talk about series later. So remember my formula from the previous slide, an equals a1, the first term, times r to the n minus 1 power. So let's write our rule. If a1 is -3 and r is -2, an is -3. I'm going to put r in parentheses because it's negative to the n minus 1 power. I have to be really careful with negatives, and I have to be really careful with order of operations here. Okay, -3 times -2 to the 6 minus 1. 6 minus 1 is 5, so that's -3, because remember, it asked me for the sixth term to the 5th power. Remember, exponents come before we multiply, so -2 to the 5th is -32 times -3 becomes +96. So A6 is 96. Can you pause it and find the fifth term for the geometric sequence? Write the rule. Here is the rule, right? Write that rule and then find the fifth term if A1 is -4 and R is 2. Pause it right now. Take a second to solve that. Okay, so you should have already solved it. You paused it. You have your answer. Did you get what I got? My A1 is -4, so AN is -4. R is 2 times 2 to the n minus 1. This is my rule for the nth term. Now if I want the fifth term, A5 equals -4 times 2 to the 5 minus 1, -4 times 2 to the fifth, 2 to the fourth. 2 to the fourth is 16, exponents before we multiply, and -64. So A5 is -64. Okay, again, if we're writing the equation, our formula is AN equals A1 times R to the n minus 1. Write the equation for the sequence and then find A7. So we're looking at the pattern 5, 10, 20, 40. A1 is the first term, so A1 is 5. And what is this pattern? Times 2, times 2, times 2, right? So the pattern R is 2. So my rule, or the equation for the sequence, is AN equals A1, 5, times 2 to the n minus 1. Then if I want to find A7, I plug it in. 5 times 2 to the 7 minus 1, 5 times 2 to the 6th. Remember exponents before multiply, so 5 times 2 to the 6 is 64. 5 times 60 is 300. 5 times 4 is 20, so 320 is your A7. Can you write the equation for the sequence 2, 6, 18, 54, and then find A6? Pause the video, do this problem. If you haven't paused it yet, you need to do the next problem. Okay, so this is what you should have gotten. My pattern here is times 3 times 3. Sometimes we can see the pattern quite easily. Sometimes we have to divide the terms to get that pattern. Usually if R is a fraction, we have to do the division. So my A1 is 2, R is 3. AN is A1 times R, 3 to the n minus 1. The great thing about the geometric sequence formula is we don't have to do any solving. We just put the two numbers in. If I want to find A6, 2 times 3 to the 6 minus 1. That's 2 times 3 to the 5th. 3 to the 5th is 243. And that's 486 is my A6. All right, what if I only have one term of the sequence and R, and I want to find the equation? So if I have this one term, I know that A5 is 32. That means when n is 5, AN is 32, and I know R is 2/3. So I'm going to plug in 32 AN. Remember that formula. A1 times R to the n minus 1. So 32 equals A1. R is my 2/3, and then n is 5, 5 minus 1. So 32 equals A1 times 2/3 to the 4th. And now I can just solve the equation. A1 is 2 to the 4th is 16. Sorry, not, that's times. And 3 to the 4th is 81. And to divide by a fraction, we're going to multiply by the reciprocal 81 over 16. That cancels, so A1, 16 goes into 32 twice. 2 times 81 is 162. So I can solve for A1, and then I can write my formula, AN, or my rule, my equation, 162 times 2/3 to the n minus 1 power. Okay, again, pause the video, try this problem. One term of a geometric sequence is a6 equals negative 96. The common ratio is negative 2. Can you write the rule? First, plug everything in and find an1. Okay, you should have done it already. My an is 96. a1 is what I'm trying to find. My r is negative 2. My n is 6 minus 1. Remember, that's my n, and that's going to be my an for finding a1. So negative 96 equals a1 times negative 2 to the 5th. Negative 96 equals a1 times negative 32. Divide by negative 32 to solve for a1, and a1 equals 3. So my formula, an equals 3 times negative 2 to the n minus 1 power. Okay, and what if we have two terms, but we don't know the a1 and the r? Can we find that equation? So if a3 is 20 and a6 is negative 160, we can plug in what we know. We know that 20 is equal to a1 times r to the 3 minus 1. And we know that negative 160 equals a1 times r to the 6 minus 1. So that's 20 equals a1 times r squared, and negative 160 equals a1 times r to the 5th. Now if I want to solve for a1, I would have divide by r squared. 20 over r squared equals a1. And then I can plug this in using some substitution. Negative 160 equals 20 divided by r squared times r to the 5th. And r to the 5th divided by r squared is r cubed. So negative 160 equals 20r cubed. Divide the equation by 20, and that's negative 80. It's not negative 80, that's negative 8 equals r cubed. Take the cube root of both sides, and negative 2 equals r. Now you can plug that back in. a1 equals 20 over negative 2 squared, which is 20 over 4, 5. So my final answer, an, is a1 5 times negative 2 to the n minus 1, and there's my rule. So take a second, review that work, pause the video, and try to apply that to the next problem if a2 equals 12 and a4 equals 3. Okay, you should have tried this one by now. an is going to be 12. 12 equals a1 times r to the 2 minus 1. And then for the second one, a4 equals 3. an is 3 equals a1 times r to the 4 minus 1. So that gives us 12 equals a1 times r, and 3 equals a1 times r cubed. So we'll divide by r to get a1 by itself. So a1 is 12 over r. We'll plug that into this equation. 3 equals 12 over r times r cubed. R cancels that out and makes it r squared, right? R cubed divided by r is r squared. So 3 equals 12r squared. Divide by 12, and 1/4, reduce that fraction, equals r squared. Square root both sides, and I get 1/2 plus or minus 1/2 equals r squared. So there's two possibilities. If I plug in positive, a1 is 12 over 1/2. 12 divided by 1/2 is 12 times 2 over 1, which is 24 when r is positive 1/2. So an equals 24 times 1/2 to the n minus 1. And then if r is negative 1/2, a1 is 12 over negative 1/2, which makes that negative 24. So we also have an is negative 24 times negative 1/2 to the n minus 1. Now we can't put just plus or minus. So these are the two. We don't really know which one it is, but we can't put plus or minus because that would imply that one could be positive and one could be negative when either they're both positive or they're both negative.